we are going to explore the topic backpatching. In compiler design, backpatching is a technique used during intermediate code generation to handle gems or branches whose target address are not known immediately. So backpatching is activity of filling up unspecified information of labels. The meaning is when we generate intermediate code, sometimes we don't know where to jump. That is if, while or go to statement. So we leave blank space and later fill it with the correct address or label. This process is called backpatching. Why backpatching is needed? Let's take an example. If a less than b, x equal to y plus z. When the compiler starts generating code, it does not know where the false part will jump to. That is if the condition fails, because the reset of the code is not generated. After finishing the reset of the code, it goes back and fill in those missing address. That is backpatching. When do we use backpatching? Backpatching is mainly used during translation of control statement like if else, while and do while, for loop and go to statements. Backpatching, the compiler maintains three types of list while generating intermediate code: true list, false list, next list. True list means address that should jump to the code executed when the condition is true. False list, it means address that should jump to the code executed when the condition is false. Next list, here address should jump to the code executed after the statement finishes. See this example. If a less than b, then statement 1. Generate code for the condition a less than b, or generate 3 address code. If a less than b, go to blank space, that is true jump. Next, go to blank space, that is false jump. Blanks are not yet known, we will fill them later. Let assume statement 1 occupies line 3 and 4. Now we know that when the condition is true, control should go to line 3. That is statement 1 is executed. So line 1 backpatched to line number 3. That is statement 1 is executed. If the condition fails, line number 2 backpatched to line number 4. Next statement is executed. This is called backpatching. The function used in backpatching make list merge p1, p2 backpatching p, I. Make list. It create a list for future backpatching. Next, merge p1, p2. It means combine multiple lists for backpatching. Backpatching p, I, that is fill all gem in list p with target address I, which means activity of filling up unspecified information of labels. In this example, if a less than b, then statement 1 is executed. In case the condition false, statement 2 is executed. First, generate intermediate code or 3 address code. If a less than b, go to blank space. So we don't know where to jump. In case condition false, give the blank space. We don't know where to jump. Assume statement 1 occupies line 3 and statement 2 occupies line 5. In the middle we are given go to blank space. And finally we are given next statement. Here a less than b, condition true. Here a less than b, when condition is true, the statement 1 is executed. So line 1 backpatch to line 3. In case condition false, line 2 backpatching to line number 5. That is statement 2 executed. The line number 4 backpatching to 6th line. So the next statement is executed. After backpatching, line number 1 backpatching to 3, line number 2 backpatching to 5, line number 4 backpatching to 6. Next, backpatching for Boolean expression. The given example a less than b or c less than d and p less than q. Here we are having the Boolean expression or and. The production rules are given. Corresponding semantic actions are there. Using the table, we will construct the annotated parse tree for the expression. In the given expression, compared to OR operator, and is having highest precedence. Before constructing annotated parse tree, write the 3 address code for the expression. In this expression, condition A less than B, C less than D, P less than Q. Here, if A less than B, go to. If the condition is true, the statement is executed. In case condition false, this line executed. Next, if the condition C less than D, if it is true, then statement is executed. And if it is false, write it go to blank space. If P less than Q, condition is true. When condition is true, the statement is executed. Otherwise, identify the false condition. So the line numbers we are given in this expression, and is having highest priority or least priority. Constructed annotated parse tree for the expression C less than D and P less than Q. In the production rule, given E tends to E1 and M E2. The corresponding semantic actions they are given. Here E produces E and M. See the production rule, M produces epsilon and semantic actions M quadruple equal to next quadruple. Write the semantic action M dot quadruple and M produces epsilon. Next, E produces E1 or M E2. E produces E1 or M E2. That is E. For the variations they are given E1 and E2. M produces epsilon and semantic action M dot quadruple equal to next quadruple. So M dot quadruple epsilon. Using the 3 address code or intermediate code, write the true list and false list. In the annotated parse tree, E produces E1 or M E2. Next, E produces ID1 relational operator ID2. The semantic actions they are given. Here, E produces ID1 relational operator ID2. ID1A relational operator less than ID2B. Here you write E produces A less than B. Next condition C less than D. It's similar to the production rule. E tends to ID1 relational operator ID2. Then write E produces ID1 relational operator ID2, that is C less than D. Now one more condition P less than Q, which is of the form E tends to ID1 relational operator ID2. Here you write ID1 relational operator ID2, that is E produces P less than Q. Now using the intermediate code or 3 address code, we will write true list and false list. In this code, assume if A less than B, condition true, then the line number 100, that is 100. Here you write E dot true list equal to 100 and false list 101. Here you write 101. Next condition, if C less than D, assume when the condition is true, write the true list number 102. Here you write 102. Next false list 103. Here you write 103. Next condition, if P less than Q, when condition is true, the statement is executed. So consider the line number 104. Here you write E dot true list equal to 104. When condition false, write the number 105 here. The given expression and is having highest priority. So we evaluate C less than D and P less than Q. In the AND operator, they are given production rule and semantic action. Production rule, E tends to E1 and M E2. So we already construct the parse tree. Look at the semantic action. The first line, backpatch of E1 dot true list, M dot quadruple. Before backpatching, we have to write next quadruple value. The production rule M produces epsilon. Semantic action M dot quadruple equal to next quadruple. In the parse tree, E dot true list equal to 102, E dot false list equal to 103. The next quadruple is going to be 102, 103. The next number is 104. That is next quadruple. So M dot quadruple equal to next quadruple value 104. Then do the backpatching. Then using the semantic action, we'll do the backpatch of E1 dot true list, M dot quadruple. So backpatch of E1 dot true list, that is 102, M dot quadruple, the value going to be 104. That is 102 backpatch to 104. Next, E dot true list equal to E2 dot true list. E dot true list equal to e2.trueList. e2.trueList going to be 104. Here you write 104. e.falseList equal to merge e1 false list comma e2 false list. e.falseList equal to e1 false list 103 comma e2 false list 105. Merge these two false lists. You will get e.falseList equal to 103 comma 105. Here we finished Boolean expression and next OR. The OR operation contains the production rule E tends to E1 or M E2. Semantic actions they are given. The given pass tree we have to write next quadruple value. See the production rule M tends to epsilon. M dot quadruple equal to next quadruple. The next quadruple value here true list 100, false list 101. The next value going to be 102. See the production rule M dot quadruple equal to next quadruple. Write M dot quadruple equal to next quadruple value going to be 102. Look at the Boolean expression or production rule and semantic actions. Backpatch of E1 dot false list comma M dot quadruple. Write backpatch of E1 false list 101 next quadruple value 102. Here 101 comma 102. Next E dot true list equal to merge E1 true list comma E2 true list. Look at the annotated pass tree. E1 true list 100, E2 true list 104. Combine these two lists and write it here. E dot true list equal to 100 comma 104. Next E dot false list equal to E2 dot false list. E dot false list equal to E2 dot false list 103 comma 105. Write it here. E dot false list equal to 103 comma 105. In this pass tree, backpatching is done from 101 to 102. Next 102 to 104. See the intermediate code 101 backpatching to 102. Next backpatch 102 goes to 104. In the intermediate code 102 backpatched to 104. So backpatching is a technique used in compiler design to fill in the missing jump address in control statement like if else, do while, for loop after the target addresses are known. It helps to handle forward jumps during code generation. The advantages of backpatching is easy code generation. We can generate code in one pass without knowing all labels in advance. And it handles forward jumps, useful when the target address of a jump is not yet known, like if else or loops. The disadvantages of backpatching is it is very hard to debug. Until the final address are filled, the code is incomplete and confusing, and limited use mainly helps for if else and while statement only, and mainly error recovery is odd. If an error occurs before patching, fixing code becomes difficult. I hope you all have understood the backpatching. If you have any doubts, feel free to leave a comment in the comment section. Thank you.